Welcome to Mr. Rafa Online Tuitions. Please don't forget to subscribe to the YouTube channel, Mr. Rafa Online Tuitions, and click on that notification button so that whenever I upload the video of this nature, you will be the first one to watch. Extraction of copper. So copper is extracted from its common ore called copper pyrite. So that is number one point that we need to know. So in the extraction of copper, the first thing that you need to know the ore where copper is extracted from, the rock that contains copper. So copper is extracted from its common ore called copper pyrite. The other name is chalcopyrite. So that is number one point that you need to understand, that copper is extracted from its common ore called copper pyrite or chalcopyrite. So its chemical formula is, so the chemical formula of copper pyrite is So this is the chemical formula of copper pyrite. So copper pyrite, it contains iron, sulfur, and copper. So remember that we are looking at the extraction of copper. So how can we remove copper from iron and sulfur? So there are three stages in the process of extraction of copper. So stages of processes in extraction of copper. Stage 1, it is what we call concentration. So concentration, it is the first stage in the extraction of copper. So concentration, it is done by froth flotation. So concentration, it is done by froth flotation. So what happens in this process of concentration? So in the process of concentration, we have a rock where copper is found, which is called the ore of copper. So that rock, it is crushed in a crusher. It is crushed. Once it is crushed, it will be mixed with oils and water. Then now, after it is mixed, the particles that contains the metal copper, they will stay floating. They will come on top in the oil. Then the impurities, such as sand, will sink to the bottom. So that is what we call froth flotation. So now you need to take note, what is the purpose of this froth flotation? The process of froth flotation, it is to remove impurities, which is sand. So that is the purpose of froth flotation. So that is stage 1. So stage 1, it is concentration. So concentration, which is done by froth flotation. So in this process, the crushed rock is mixed with oils and water. Then the particles that contain the metal copper will stay floating, okay, in the oil. Then the impurities, which is sand, will sink to the bottom. That is what we call froth flotation. Okay, then you need to take note that the purpose of this froth flotation, it is to remove impurities, which is silica, which is sand. So now stage 2, it is roasting in air. That is stage 2. So what happens in this process of roasting in air? So what happens in this process of roasting in air? So now the ore of copper, which is the rock, contains copper. It is roasted strongly in air. So the purpose of this process, it is to remove sulfur. That is the purpose of roasting in air. So the ore is roasted in air strongly to remove sulfur. So to remove sulfur. So that is the purpose of roasting the ore in air. So now let's look at the chemical equation. So we have the ore plus oxygen. So that is air. So plus oxygen. So what we are going to have, it is copper 1 sulfate plus iron 2 oxide plus sulfur dioxide. So that is what we are going to have. So this is the second process where the ore of copper, it is strongly roasted in what? In air to give us copper 1 sulfide plus iron 2 oxide plus sulfur dioxide. So the purpose of this reaction, it is simply to remove sulfur from the ore. So now let us balance that equation. So that is the balanced chemical equation. So we have copper pyrite plus oxygen. We are going to have copper 1 sulfate plus iron oxide plus sulfur dioxide. Then from here now, we are going to remove iron oxide. So how do we remove iron oxide? We remove iron oxide by reacting with silicon dioxide. So iron 2 oxide plus silicon dioxide, we are going to have iron silicate, which is the slag. Iron silicate, which is the slag. The last thing that we are going to do here, we are going to reduce copper 1 sulfide to copper by strongly roasting it in what? In air. So that's what we are going to. So copper 1 sulfide is heated in air to produce Brewster copper. So we have copper 1 sulfide plus oxygen. We are going to have copper metal plus sulfur dioxide. So there it is produced in the liquid form. So we can balance that equation. So that is a balanced chemical equation. So copper 1 sulfate plus oxygen, we are going to have now copper. So we have copper metal plus sulfur dioxide. So the sulfur dioxide that is produced in this case, it is trapped and it is used to make sulfuric acid, which is also used in copper production. Sulfur dioxide is trapped and used to make sulfuric acid, which is used in copper production. And you need to understand that this process of extracting copper, it causes pollution. Why does it cause pollution? It causes pollution because this process, it often involves the release of the pollutant to the environment. So which is sulfur dioxide. This sulfur dioxide, sometimes it is released to the environment. So it is going to cause pollution. So that is the reason why this extraction of copper, it causes pollution. So process 3. So process 3, it is called electrolysis. So what about electrolysis? So electrolysis is a method that is used to refine copper from its blister copper. So electrolysis, it's a method that is used to refine, to purify copper. So that is the main essence of electrolysis method. It is used to purify copper. Now what happens in this electrolysis? So the impure copper, it forms the anode, and the pure copper forms the cathode. That is in the electrolysis. And the electrolyte that is used in this electrolysis, it is copper 2 sulfate. That is the electrolyte that is used. So this is the electrolysis cell. So this is what we call electrolysis cell. So what happens here? So this is the positive charge, which is anode. So the anode, it's the one that contains the impure copper. So this is the anode containing impure copper. And this is the electrolyte, which is copper 2 sulfate. Copper 2 sulfate solution. So this electrolysis cell, it uses electricity. It uses electricity. So now once electricity there, it is powered. this anode, which contains the impure copper, it will begin to dissolve, forming the copper ions. Then as it is dissolving, forming copper ions, the impurities, they will fall on the bottom. The impurities here, they will fall on the bottom. So these are impurities. So that impurity, that's what we call the sludge. So these are impurities that falling at the what? At the bottom. So remember that the anode is dissolved, forming the copper ions. So the copper ions, they will begin to move from the anode going to stainless steel cathode. So these are copper ions. So copper ions, they are moving from the anode going to cathode. So this is stainless steel cathode, which is attracting the pure copper. So the pure copper is attracted to the stainless steel cathode. So that is what is happening. So remember that the cathode, it is negatively what? Charged. It is negatively charged, so it is attracting the positive charges of copper. That the anode, which is the positive charge, which is the impure copper, it gets dissolved, forming copper ions. So now the impurities, they will fall at the bottom. So that is what we call sludge. So the copper ions will move from the anode to the cathode. So remember that the cathode is negatively charged. So the negative charges, they will attract the positive charges of what? Copper. So at the cathode, that is where the pure copper will be. So the mass of the anode will reduce, then the mass of the cathode will do what? Will gain. So that is what is going to happen. So now let's look at the reaction at the anode. So reaction at anode, remember that anode, it is forming the copper ions. So the reaction is going to be copper, which is a solid, from the solid copper forming the copper ion, which is in aqueous. So plus C electrons there. So that is a balanced equation. Then the reaction at the cathode. Remember that the cathode, it is receiving the copper ions, forming a solid copper. So we have copper ions forming copper. So these are the two reactions that is taking place at anode and at cathode. So now we look at the uses of copper. So number one use of copper. Copper, it is used to make electric cables or electric wires. So they can ask you what makes copper to be used to make electric wires or cables. The reason is simple. It is because copper, it is a good conductor of electricity. So number one, making electric cables, because it is a good conductor of electricity. So that is what we call the Yusuf property. So number 2, copper, it is used to make alloy, e.g. we have brass and bronze. Those are the 2 alloys of copper. So why is copper used to make an alloy? Because it does not corrode. Because copper does not corrode. Then number 3, so copper is used to make domestic water pipes in plumbing. So why is it used to make water pipes, or why is it used in plumbing? Because it does not corrode and it is not poisonous. And it is not poisonous. So the last party, we look at the alloys of copper. So number 1 alloy of copper, it is brass. Copper, it is 80% in this alloy brass and 20% zincy. So how is this brass used? Brass, it is used to make boats, to make clocks, to make musical instruments. So number 2, bronze. So bronze, it is 90% copper plus 10% tin. So bronze, it is used to make coins. It can be also be used to make medals, to make the trophies. So these 2 are the alloys of copper. I hope you have enjoyed the extraction of copper. Watch out for the extraction of zincy in my next video. Please don't forget to subscribe to the YouTube channel, Mr. Rafa Online Tuitions, and click on that notification button. And don't forget to put up a comment and a like.